So today's presentation, it's going to be about training or like transfer learning on and training a pre-trained model on image classification and perform and create our own mushroom image classifier using images from iNaturalist users on different mushroom species that can be found in my region, actually. So yeah, I was looking for some of the most common mushroom species in my area, and there are like some famous ones, like the one that has its own emoji, the Amanita muscaria. I think it's also present in the US, and in this case, Amanita muscaria is the scientific name. And yeah, for this particular case, there is even a thumbnail image of the mushroom. Then I will use the iNaturalist search function from the Wolfram function repository. So you can use a research function, and yeah. So for here, we can the first input of iNaturalist search is going to be the species of the mushroom. You can either use the entity or just a string with a scientific name. Then I'm specifying that I want to retrieve observations that contain images, and then I want a research grade observations so that they are confirmed by other iNaturalist users that that mushroom species is the right one. And for this particular case, I just wanted like 50 images for each species. So I'm using max items 50. By default, it's retrieving 200 if there are 200 observations at least for the species. And then I was asking for only European mushrooms, because I don't know if there are like some varieties on the same species. I think for Flyga Greek, there are some varieties of Amanita muscaria that are yellow, but in my area, all of them are like red with a white dots. So once I get the data here as an example, I think I showed in the previous days. That's the data set for one of the observations, the first observations from this data set. And what we are interested is on for this particular problem is to get the image URL. You can, if you want to work with the smaller images, you can use a square image URL. It's going to be a smaller version and lighter, but you can see it's super small. It depends on the picture of the observation that will be like suitable for training a classifier, a light classifier version. For the best results, I was using image URL, so the original size image. So this is the image for the first observation of this data set. And then I wanted to kind of import data, create a training set on the most common toxic mushrooms I have in my area, and as well as the edible mushrooms. And just as a side note, the final kind of classifier that I'm presenting here, it's not meant to be kind of be used for people to decide if one mushroom can be eaten or not. So I don't want anyone to get into hospital because they trusted this classifier. So what we have the list of mushroom species. I'm kind of creating this few functions on retrieving the different species images, and I'm doing some pre-processing on the images. So I'm kind of resizing the image to a size that it's easy to be handled by my laptop for the transfer learning problem. So these are the resulting images. So there, I'm also like using square images. So with image resize, you can use image crop first to get a square image, and then image resize to get a smaller size of the images. And then what I'm gonna do is to export uh, the images and save them in a folder in my laptop. And then once we have the training set, what I'm gonna do is kind of to create the examples for the training set using the class labels with a scientific name plus the tag toxic or edible. And once I've done all these for these, I think I had like several, like 19 examples of mushrooms. We will have a total training set with 850 examples. You should use random sample on these examples, and then create a training like use like with as a rule of the thumb of 90% of them are going to be used for the training set, and the rest 10% are going to be used for the testing set. For this particular example, I was using a pre-trained model from the Wolfram Net repository. It's the same one that has been used to train the image identify function built in the Wolfram language. This is also available on the Wolfram Net repository, and in Mathematica you can just use net model and specify the name of the model, and you will download from the net repository that model. For the transfer learning problem, here what we want to use is the feature extractor, which is the convolutional part of this pre-trained model, and we want to remove the last 3 layers, which are the ones kind of use it for classifying the 4,315 classes of objects. Yeah, you can use so the size of this network is 60 megabytes. So it's you should, since our end goal is to deploy this trained neural network into our phones, you should be aiming to not to have like a neural network with a smaller size than 100 megabytes. There are like some pre-trained models that are super large that can be even gigabytes, so you don't want that on your phone. So here I'm using the nettake to get the convolutional part of the pre-trained model. So that's using from the first layer until the global pooling layer. So this one here, and this is and once we have this subnet or this mainnet or this feature extractor part of the net, then we will use net join to attach our kind of new classifier with 17 species of mushrooms from our training set. So here, what we are gonna do is to create this to attach at the end of this linear layer with 17 classes, and then for the probabilities, the softmax layer, plus adding the net decoder with our customized class labels for these 17 species of mushrooms. And once we have this joined net, we can then use net train to train the net on our training set. And that's important, specifying the learning rate multipliers that we want only to train the weights for the linear layer of our classifier, and keep the pre-trained weights fixed, so that we're like kind of freezing the future extractor of the image identify net. And then I'm including a validation set based on the training set, which is like a 10% of the training set. Use it for the validation. And then you can specify parameters like the max training rounds. Here I'm using 15. And then the method is a stochastic gradient descent. And for this particular case, it took me like 9 minutes to train this image classifier. And then once we have the trained net, we can use classifier measurements to kind of see how well is performing this kind of trained net. And for that, we need to specify that we want the testing set for checking for example, the confusion matrix plot on that classifier measurements. It's the following one. So it seems it did a decent job for most of the mushrooms. There are some edible mushrooms that were actual edible ones, like Lactarius delicious, and it was confused by a toxic one, and vice versa. So you should be careful. Don't trust this neural network that much. And a good thing from classifier measurements, a good property to know about classifier measurements is this best classified examples that will give you a grasp on what was going on the network, and also the worst classified examples. So you can check here what was misidentified or was identified incorrectly with the net. And we can see some of the images, like for example, here I see a rotten mushroom, so it's not an easy task, I guess. And some of the mushrooms have different angles. They were upside down. One is covered with leaf, so maybe one way. So it's not surprising that it could not identify some of these mushrooms. And for the best classified examples, you can see that they look like perfect pictures of the mushroom species. So this is one of the test examples from iNaturalist users, and it identified correctly. For example, we can test it using the trained net on and checking for the top probabilities. A good thing to do once you have the trained model is to save it and export it. So if you want to use it again, you don't need to retrain the whole neural network again. And a good way to do that is to just export it using the Wolfram Language net format, and that will save store in your local computer the model. So later on, you will be able to use just the import function on that file and be able to use the trained model again, even if you switch off the session. So in the second part, for deploying the neural network to the iPhone, what's going to be needed is to convert this Wolfram language model into ONNX. ONNX is an open format for representing machine learning models. That was I think we might want to check that. It was like a kind of an international effort and with many different companies to have a neural network format file or framework to be able to convert from different machine learning frameworks. So the good thing is that in Mathematica 12.2, there is we have the availability to export a Wolfram language neural network into ONNX, and it's as simple as just using export and specifying that we want to export as ONNX format file. Once you export the model, one thing that you might want to do before going on is to check that the conversion was successful. So we can import back the ONNX model into Mathematica, and you will see that there was a difference between the original model and the kind of the round trip model, the imported model. One is a net chain, and the other is a net graph. And you will see that the input port is an array, and the output port is vector size. So that means that ONNX is not storing the net encoder and the net decoder. So the image and the classes are lost while exporting to an ONNX model. So ONNX models don't have the encoder and the decoder. So that's something that you will need to specify once you import an ONNX model, is to obtain kind of to use, for example, a net replace part on the ONNX model, and specify that you want to include as an input the encoder that we used earlier, and also as well as the decoder containing the classes for the mushroom species in this case. So you can use the net extract to get the net encoder and the net decoder from our Wolfram language neural network, and then use net replace to get that, and have the net, what's so-called the addressed neural network. And then we can check that for both the round trip model and the original Wolfram language model have the same top probabilities. All right, so that was working well. And as a final step, since I want to deploy the neural network into my iPhone, we need kind of to convert again the ONNX model into CoreML. CoreML is the machine learning kind of framework for Apple devices, and Apple released an open package on Python called CoreML tools for converting a variety of models into CoreML, which is the .ml. So for this, I will need to use the kind of like the external evaluator for Python within Mathematica. I put a link into our references on how to configure Python for external evaluate within Mathematica. And then as well, we will need to install with using the terminal a couple of extra packages, the CoreML tools package from Apple, as well as the ONNX package. So the basic idea here is that we will need to specify in this CoreML tools package the net encoder and the net decoder of the model, since the ONNX model kind of doesn't have this specification. The good thing is that CoreML uses a similar way of specifying the image encoder and the decoder. So we will be able to do that. One thing I've faced once I was doing this project is that the image encoder in CoreML is different than the Wolfram image encoder. So they have we can check that for our particular case in this model in the Wolfram language model, there is a mean image and as well as the variance is set to known, and then in the CoreML they are using the pixel values are ranging from 0 to 255. In our cases, they're ranging from 0 to 1. So then this is something that we will need to include in the conversion from ONNX to CoreML, as well as specifying the classes of the mushrooms. And for this, we can use a text file just on the different mushroom species. We can use a string rifle, and this will create a text file with a new line per each mushroom species. And once we have this, we will kind of use this Python code snippet and importing the CoreML tools package, then specifying the path directory where I stored the ONNX exported model. And for this, we want to specify which is the input layer, and then that we want as input, we want images that needs to be that the mode of the model is going to be a classifier, not a regressor. And then these are also important parameters, which are the preprocessing arguments for the net encoder in our model. So and finally, we need to specify the file where we have stored the class labels. With all these, we can just save the converted model, this ML model, and if everything goes fine, it's converting all the layers, and finally we should see a kind of a compilation message that was done correctly. And once we have that, one can directly check that the model is working well directly on the laptop using CoreML tools. So I was testing with some images that the predictions were correct. And for this particular image that we tested before, it's almost the same probability. So it seems that the conversion was successful. There are some minor differences due to the way that the numeric arrays are treated, but it's less than kind of a few percent. So I would say that the conversion was working well. And as the last step, once we have the CoreML model, it's more or less straightforward to deploy it into the iPhone. So for this particular case, if you want to deploy it into iPhone, you will need to register to get the latest Xcode. So this is Xcode beta. So you will need to register as an Apple developer. For this particular case, you won't be you don't need to know about Swift programming language because it won't be necessary almost in this example. So Apple kind of released this example on classifying images with Vision and CoreML. Yeah, I think we can just check briefly. So this is the this Xcode project is the one I was using since it's freely provided to us. We can import it, open the Xcode project, and then what we want to replace is this MobileNet ML model, and here put our particular mushroom classifier ML model. Xcode has this nice thing of previewing the predictions, so we can test some of the mushroom images directly on the MacBook Pro and check that the classifier is behaving correctly before deploying into the phone. So we only need to modify the Swift code in one of the lines. So changing the name of the mobile net into our mushroom Wolfram net, and then also specifying the kind of development thing change. And then it's just pressing the kind of deploying it connecting to your iPhone and then deploying it, and the phone your phone will open the app that we just created. So I was testing in some live mushrooms, and most of them were like identified correctly. Like for example, this Lactarius delicious. I have some other examples. Yeah, I think I have even one video recorded. Let me see. I think it's this one. So let's check it. So this is the kind of a screen recording of my iPhone into one of my hikes and checking out this mushroom, and it was identified correctly as Macrolepiote procera, which is edible. But again, don't use it for your cooking. The mushrooms can be deadly. And I think with this I will finish my presentation on how to deploy image neural network into your phone.